Hi, I'm Derrick.
And I'm Shila, and we're fellow ambassadors with the Southwest Fire Science Consortium and the Arizona Wildfire Initiative.
And we will be walking through the high school Fire Ecology Learning Lab Informal Educator Kit. There are two letters, one to be sent to teachers during the early stages of outreach and one to be sent home with students to inform parents. This is a good thing to keep in mind while you are teaching, as affected students or teachers may want to still hear the lesson.
A lesson on fire ecology has the potential of triggering past trauma in individuals who have had negative experiences with wildfire. In an effort to bring kindness and awareness to the center of this conversation, these letters aim to identify any student or teacher who may not want to participate in this lesson and give them an early opportunity to sit this one out. The fire behavior lesson does require burning up to 6 Matchstick Forest. This will probably have to be done in a fire-safe area outside, such as a basketball court or sidewalk, or inside in a smoker fume hood. Notify your school of this burning well beforehand. Monitor weather conditions day of, and absolutely no burning on a red flag day or when it's too hot or windy, of course.
High school students like being treated as adults. They are beginning to navigate the next steps in life, so please be prepared for career-related questions.
When you first arrive at the school, check in at the front office. Go over classroom dynamics with your teacher and how you expect the lesson and any disruptions to go. Build your first Matchstick Forest by putting matches in every single peg hole just like this. Lay out all your handouts and materials in a way that makes sense to you.
Introduce yourself, your job or agency, give a brief explanation of how you got started in this career and what you usually do in a day.
Also, remember you're a subject expert. Avoid using acronyms, jargon, and generally big words. High schoolers should be treated as adults that can make complex connections, but students and even teachers are unlikely to tell you when they're confused.
It's important to set lesson expectations now and before you start working with fire. It's also important to repeat these lesson expectations throughout your lesson. Now show students the Matchstick Forest. Ask students to hypothesize how they think the Matchstick Forest will burn and ask them to record their hypothesis in their worksheet. Now transition to your designated burning site and position students where they can all observe from a safe distance. Now light the trays on fire and ask students to observe and write down their observations in their worksheet. After burning, allow students to share and discuss their observations. Now transition back to the classroom where students can begin to build their own and unique Matchstick Forest. The first step of the experiment is to introduce the fire behavior triangle. This is similar to the fire triangle, but it does not display the 3 things fire needs to burn. This triangle displays the 3 environmental aspects that largely influence fire behavior. You can introduce the fire triangle by saying something like, "Now I've asked you a few times to think about how fire burns. In a wildfire situation, what kinds of things might be influencing how fire burns?" Students can then give out answers, and you can guide them to the 3 answers of topography, weather, and fuels. Remind students that fuels keep fires burning. Some wildland fuels include things like large branches, trees, leaves, and any area-specific fuels you can think of. Give students time to brainstorm and share their thoughts before moving on.
During this discussion, connect the fire behavior triangle with your Matchstick Forest and their observations. Why do they think the fire burned as fast or as slow as it did? What aspect might have influenced this behavior? What might this aspect look like when it's influencing a wildland fire? Next, introduce what students will be doing for their experiment and handout materials. Each group will get a card with instructions on how to build their own Matchstick Forest, displaying one of 6 environmental conditions that influence fire behavior. Each group will be changing 1 variable. They will also get 1 MDF board and 1 box of matches, although they won't use them all. these instructions, use your best judgment to make sure the forests actually catch and burn at one point. Lay down trees and ladder fuels strategically and help students to make sure the matches touch at least a fair amount in these examples.
Now, students have 5 to 10 minutes to build their matchstick forests. Some groups will be building forests exactly like the one you burned in the beginning, but changing a variable during the burning. If students need more time, that is okay, but you might not get to watch each forest burn one by one. After students are done building their forests, relocate to your burning spot. Make sure your spray bottle is full, you have your fire extinguisher, and students have their worksheets to record their observations. When burning, you will want to start with the most simple concepts so you can build off of these ideas. For example, burn forests concerning density before introducing slope or weather. Set clear consequences for not listening or not following directions again, especially when lighting and observing the fire. Show that you are serious and follow through with consequences for disruptive behavior immediately for this portion.
Burn the matchstick forest either one at a time or all together as time allows. It's best to go one at a time so that you can discuss and brainstorm after all the matchsticks are out and students have had time to come up with their own questions or ideas about what happened. For example, a final explanation of the slope card could look like, "That one really took off." That's because when a wildfire is burning at the bottom of a forested hill, heat from that fire is going to rise. This heat is transferred via a process known as convection, and as that hot wind sweeps up the hill, it sort of preheats the trees that are uphill from the actual fire front. All of the water sort of gets cooked out of these trees, which makes it easier for the fire front to actually consume them once it reaches them upslope. But it won't happen going down the slope because the heat from the fire will only rise. You can put out the matchstick forest however you would like by letting them smolder or spraying them with your spray bottle. After you have burned all your forest, transition back to the classroom to discuss forest suppression.
Show the images of the ponderosa pine forest throughout the years. This illustrates how the absence of fire over the years has led to an increase of fuel loads. About how this forest over the years relates to the matchstick forests you burn, and identify which images exemplify some of the matchstick forest conditions. Emphasize that this is the same view of the same forest over the years. How has it changed? Are there the same amount of trees? Are they the same size? What does this mean for how a wildfire would progress through here at different times? If time allows, around 15 minutes, you can take this time to facilitate a quick Q&A on your career and talk about the importance of careers in conservation. Sharing your own experiences honestly is a good way to connect with students. Also, feel free to discuss career opportunities that differ from your own, but align with the students' interests or some of the partners you work with.
If the heat transfer homework is being assigned, discuss the 3 heat transfer methods here. Convection is the transfer of heat via a fluid, so think a gas or a liquid. When you hold your hand above a candle without touching the flame, or the slope matchstick forest example are both great examples of convection. Conduction is the direct transfer of heat via physical contact, so when you hold a hot metal spoon or a flame front contacting a tree. And radiation is the transfer of heat via electromagnetic waves, so when the sunlight heats the earth or when embers ignite fuels while being carried by the wind. Make sure you know beforehand if your class is completing the homework assignment. This homework involves students writing on the backside of their experiment about climate change and how the heat transfer methods play a role in the different aspects of the fire behavior triangle in the final reflection question. If time allows, it can also be done at the end of class. Thank the students and their teacher for having a discussion with you about wildfire, fire behavior, and their very important futures. If you have any cool stuff, now is the time to pass it out. That is the high school Fire Ecology Learning Lab Informal Educator Kit. If you need any more resources, have any questions on these kits, or need any assistance with outreach or acquiring a kit, please reach out to the Southwest Fire Science Consortium.